In today's video, let me explain about the differences between Cannizzaro and Aldol reaction. Okay, let me write Aldol first. Aldol versus Cannizzaro reaction, right? Now, the important point about Aldol reaction is there must be alpha hydrogen. There must be alpha hydrogen, and in case of Cannizzaro reaction, no alpha hydrogen must be there. Both reactions are taking place in basic medium. This is also in basic medium. This is also in basic medium. And in today's video, I'm going to give some intramolecular Aldol reaction and intramolecular Cannizzaro reaction. But before that, let me give an example of Aldol reaction. In Aldol reaction, let me give this example. CH3 CH2 C double bond OH. This is an aldehyde in which alpha hydrogen is present. 2 alpha hydrogen is present here. So if this is reacted with a base, for example sodium hydroxide or barium hydroxide, then beta hydroxyaldehyde will be formed. In this case, beta hydroxyaldehyde. So the product will be like this. Let me write the product. CH3 CH2 CHOH, and to this carbon atom beta carbon will be attached. This is the alpha carbon will be attached. This is the alpha carbon atom. One of these two hydrogens will go to this oxygen. This one is the hydrogen, and to this carbon atom this methyl group will be attached, and this will be our product. So this is the alpha carbon atom, this is the beta carbon atom. So beta hydroxyaldehyde is formed. So if it is heated, if this aldol, this is aldol because aldehyde as well as alcohol is present in this compound, and if it is heated, then aldol condensation product will be formed. So when this aldehyde is reacted with sodium hydroxide, and if it is heated, then also the aldol condensation product will be formed. So aldol condensation product will be CH3 CH2 CH double bond. This two hydrogen will go out with one oxygen atom of one molecule, and so a double bond will be there, and to this carbon atom methyl group will be attached. This will be our aldol condensation product. So how can this product be written without any mistake? Let me give you the trick for this reaction. The trick for this reaction is, if we want to write this aldol product. This is alpha, this is beta, and this compound is alpha beta unsaturated aldehyde, right? Okay, now how to write this aldol product, aldol reaction product with trick? Let me give you that trick. This is one molecule of the aldehyde, this is propanol, and let me write this hydrogen below so that I can give the clear bonding between the two molecules. Two molecules of the compound will be used, and for the other, let me write this in this way, CH2. Let me, I'm going to write this aldol condensation, aldol product, right? So let me write these two hydrogens in this way. This is the alpha carbon atom of the second molecule, and two hydrogens are there like this, and to this alpha carbon atom, beta carbon atom is also there, so CH3 is there, and this will be our CHO. So in the trick, let me show the trick like this. This hydrogen will go to this oxygen atom, this is the hydrogen, right? And the pi bond will be shifted here to form a bond between this carbon and this carbon atom. This is the new bond, right? This is the new bond. Okay, so I have told how this aldol reaction product can be written. This is the trick. Just apply this trick for other compounds also. And for writing this aldol condensation product, the trick is like this. This is our one molecule of propanol. Let me write C and O double bond like this, and to this I need to attach the alpha carbon atom of another molecule, same molecule, right? So this will be our another propanol molecule, and this oxygen and these two hydrogens will form water molecule, and this carbon and this carbon will be attached by a double bond. This is how the aldol condensation product can be written without any mistake, right? This is about aldol reaction. Okay, let me give an example of Cannizzaro reaction. Cannizzaro reaction. Okay, this is Cannizzaro reaction. In Cannizzaro reaction, there must be no alpha hydrogen, so we can give this formaldehyde because there is no alpha carbon atom in this carbonyl compound, and so Cannizzaro reaction will take place in formaldehyde. Another molecule in which Cannizzaro reaction will take place is benzaldehyde. Okay, so I am giving this example of formaldehyde, and if it is reacted with potassium hydroxide 50%, then Cannizzaro reaction, one important point of Cannizzaro reaction is that this is a disproportionate reaction, means oxidation and reduction takes place to this carbon atom to form an alcohol and carboxylate ion. Okay, so there is one carbon atom in this molecule, so I need to form an alcohol of one carbon atom, which is methanol, and sorry, and this is methanol CH3OH, and one carboxylate ion containing one carbon atom only. So that carboxylate ion will be formate ion. Okay, this is formate ion. I'm not able to write this here, So let me rough here. Plus format ion is this one. Okay, this is a disproportionate redox reaction. Two molecules of formaldehyde will be used. One will be reduced to alcohol and one molecule will be oxidized to carboxylate ion. Okay, so now this is also in basic medium. Let me give an example of this Cannizzaro reaction, cross Cannizzaro reaction. So in this case I need to take two different aldehydes in which Cannizzaro reaction can take place. One is formaldehyde and another one is benzaldehyde. So if it is reacted with 50% KOH, then this will be a cross Cannizzaro reaction because we are taking two different aldehydes, right? So in this case also one carboxylate ion and one alcohol will be formed, and the trick here is write the alcohol of that compound in which steric hindrance is large, right? So due to this benzene group, which is a larger group, we must make alcohol of this compound. This is benzyl alcohol, and the carboxylate ion must be of the molecule having less steric hindrance or smaller group. So the carboxylate ion is format ion. Okay, this is the point. So there is a mechanism for this reaction in my another video. Please go to the playlist, and there will be playlist of the name reaction. You'll get that in that particular playlist. Now I'm going to give one example in which cross Cannizzaro intramolecular Cannizzaro reaction will take place. Suppose this is the aldehyde in which now Cannizzaro reaction will take place. The product will be one of this aldehyde. Two aldehydes are here. One of the aldehyde will be oxidized to format ion. This will be like this, and another one will be reduced to alcohol. So this will be the product. So let me show how this product is formed with the mechanism. So this will be the mechanism. Let me change the color. Okay, now either of this carbon atom can be attacked by this OH minus ion because this is symmetrical. So this will be formed like this. So we can get O minus ion. Here will be OH and this is hydrogen. When this returns here, this hydride ion will be attacking this another carbonyl carbon atom. Okay, another carbonyl carbon atom as nucleophile. This is an intramolecular nucleophilic attack by hydride ion. So this will go like this. So this will look like this. This will be O minus, and here hydrogen will be there, and this will be converted like this. This hydrogen goes here, and to this carbon atom OH is attached, right? So if it is reacted with the base and water, this OH minus ion will abstract one hydrogen from water, and this carboxylic group will react with the base to convert it into carboxylate ion and to convert this oxide ion into alcohol. So this will be CH2, this is CH2, OH, and then this carboxylic group will be converted into carboxylate ion. So this is our product, right? Okay, let me give one more example in which I am taking formaldehyde and acetaldehyde. This is acetaldehyde, right? Now and if it is reacted with base, what will happen? Now here the point is, this is alpha carbon atom, alpha hydrogen is present here, and this has no alpha hydrogen. So to this molecule Cannizzaro reaction can take place, and to this molecule Aldol reaction can take place, right? So which product we need to form, that is the question here, right? So for that we need to know about Aldol reaction. Aldol reaction is started by an acid base reaction. Okay, so and the Cannizzaro reaction is started by a nucleophilic attack by the OH minus ion, and in Aldol reaction the OH minus ion will abstract one hydrogen from alpha carbon atom as base, and we know that acid base reaction is more reactive than nucleophile electrophile reaction, right? So we need to form Aldol product here. Now let me give the mechanism of this reaction first, so that I can write the product correctly. I do not know the exact product, so let me write the mechanism to write the product, right? So the mechanism is, this is the let me show one alpha hydrogen here, because this will be abstracted by the base OH minus ion. So OH minus ion will abstract one hydrogen from alpha carbon atom as base. So to form, this will form an enolate ion, right? So this will be our enolate ion, which is stable due to resonance. This can go here, this can go here, so this is stable due to resonance, right? So in the next step, this enolate ion, which will act as a nucleophile to attack, this is the nucleophile, and this will attack the formaldehyde to this, and nucleophile can easily attack because there is no steric hindrance. So this can attack to another molecule of acetaldehyde as nucleophile, but the chances of this enolate ion to attack this formaldehyde is more, because there is less steric hindrance in this case. So this will attack to this carbonyl carbon atom to form an intermediate like this. Let me draw here. This will become what? CH2 will remain same, O minus, and then to this carbon atom CH2 will be attached like this. So if it is reacted with water, then this O minus will abstract one hydrogen from this water to form this compound as the product. This is CH2, right? To this CH2 OH will be attached, and CH2 C double bond O and H. This will be our alpha beta hydroxyaldehyde, right? So this is our beta hydroxyaldehyde. This will be our measure product. So let me write this product here. This will be CH2OH, right? To this CH2 is attached and a CHO. This will be our major product, which is the aldol product. In this case, we can form the Cannizzaro product also. We can form another simple aldol product also, but this aldol product will be our major product. Okay. Okay, let me complete this video here. Thank you. Please share this video to your friends if you like, and if you are new to the channel, please subscribe to this channel. Thank you.